The National Electrical Code, or NEC, and OSHA have specific guidelines for motor control that this setup appears to violate. NEC Section 430.102G mandates that motor controllers must be within sight of the motor unless they can be locked in the off position. This is a safety measure to prevent someone from inadvertently starting the motor while someone else is working on it. Section 430.102H further states that a motor controller cannot be used as the disconnecting means unless it also serves as a disconnecting means. This means that the breaker isn't intended to be the primary on or off switch for regular motor operation. OSHA Standard 1910.303 requires the use of lockout and tagout devices on control switches and circuit breakers controlling motors. This is a crucial safety procedure to ensure that the motor remains energized during maintenance or repair. Using only a breaker poses several safety concerns. Firstly, there's the arc flash hazard. Opening and closing a circuit breaker while the motor is running or under load can create an arc flash. An arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and even death. It's a serious safety risk that should be avoided at all costs. Secondly, there's the risk of accidental restart. Simply pushing the breaker in without verifying the motor's status could lead to an unexpected restart, which could injure someone working on or near the conveyor system. Thirdly, a circuit breaker used as the sole control lacks essential motor protection. It doesn't provide overload protection, short circuit protection, or phase imbalance protection, which are all crucial for preventing motor damage and fires. Overloads occur when the motor draws excessive current for an extended period, which can cause the motor to overheat and fail. Short circuits are sudden, high current faults that can damage the motor and the electrical system. Phase imbalances can occur in three-phase systems when the voltage or current in each phase is not equal, which can also damage the motor. So, what are the alternatives? Firstly, a motor starter is a dedicated device designed specifically for controlling motors safely and reliably. It provides overload protection, phase protection, and start and stop capabilities, ensuring that the motor operates within safe parameters. Secondly, a remote control panel can be installed near the motor, allowing for safe operation from a distance. This eliminates the need to open the panel box and manually switch the breaker, reducing the risk of arc flash and accidental restart. Thirdly, a safety interlock switch can be installed on the panel door. This switch prevents the motor from starting if the door is open, further reducing the risk of accidental restart. A safety interlock switch is a mechanical or electrical device that prevents the motor from operating when the panel door is open. The following steps should be taken. Firstly, inform the individual about the code violations and safety hazards associated with using a breaker as the sole control for the motor. Explain the risks of arc flash, accidental restart, and lack of motor protection. Secondly, recommend the installation of a motor starter or other appropriate control device. Explain the benefits of using a dedicated motor control device such as overload protection, phase protection, and start and stop capabilities. Thirdly, emphasize the importance of following safety protocols, including lockout and tagout procedures, arc flash risk assessment, and proper maintenance. If the individual insists on using the breaker as a control, make sure that additional safety measures are implemented, such as a safety interlock switch and adequate arc flash protection. Remember, safety should always be the top priority. There are several types of motor starters available, each with its own advantages and disadvantages. The simplest type of motor starter is a manual starter, which consists of a switch or contact that is operated manually to start and stop the motor. Manual starters are typically used for small motors that do not require overload protection. Magnetic starters use an electromagnet to control the contactor that starts and stops the motor. Magnetic starters offer overload protection and are typically used for larger motors. Solid-state starters use electronic components to control the motor voltage and current. Solid-state starters provide smooth starting and stopping, overload protection, and phase protection. Variable frequency drives, or VFDs, are the most sophisticated type of motor starter. The FDS can control the motor speed and torque, as well as provide overload protection, phase protection, and energy savings. The selection of a motor starter depends on the motor size, the application requirements, and the budget. The NEC and OSHA regulations are in place to protect workers from electrical hazards. Failure to comply with these regulations can result in fines, injuries, or even death. It is important to understand and follow these regulations to ensure a safe working environment. Arc flash is a serious hazard that can occur when electrical equipment is energized. Arc flash can cause severe burns, blindness, and even death. It is important to take precautions to prevent arc flash, such as wearing appropriate personal protective equipment, or PPE, and following safe work practices. Lockout and tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Proper maintenance is essential for ensuring the safe and reliable operation of electrical equipment. Maintenance should include regular inspections, testing, and cleaning. Electrical equipment should be inspected for signs of damage, such as cracked insulation, loose connections, and corrosion. Testing should be performed to verify that the equipment is operating properly. Cleaning should be performed to remove dust, dirt, and other contaminants that can cause the equipment to overheat or fail. By following these recommendations, one can help to ensure the safety of workers and the proper operation of electrical equipment. Motors require protection against overloads, short circuits, and phase imbalances. Overload protection is typically provided by an overload relay, which is a device that senses the motor current and trips the circuit breaker if the current exceeds a preset value. Short circuit protection is typically provided by a circuit breaker or fuses, which are devices that interrupt the current flow in the event of a short circuit. Phase imbalance protection is typically provided by a phase monitor, which is a device that senses the voltage and current in each phase and trips the circuit breaker if the phases are unbalanced. A motor starter is a device that provides safe and reliable control of a motor. A motor starter typically includes a contactor, overload relay, and other protective devices. The contactor is a switch that is used to start and stop the motor. The overload relay protects the motor from overloads. Other protective devices may include a short circuit protection device and a phase monitor. A remote control panel allows for safe operation of a motor from a distance. A remote control panel typically includes start and stop push buttons, indicating lights, and other control devices. A safety interlock switch prevents a motor from starting if the panel door is open. A safety interlock switch is a mechanical or electrical device that is mounted on the panel door and connected to the motor starter. When the panel door is open, the safety interlock switch prevents the motor starter from energizing the motor. The NEC and OSHA are two of the most important sources of information on electrical safety. The NEC is a set of standards for the safe installation of electrical wiring and equipment. OSHA is a federal agency that enforces workplace safety regulations. The NEC and OSHA regulations are designed to protect workers from electrical hazards. Compliance with these regulations is essential for ensuring a safe working environment. Arc flash is a serious hazard that can occur when electrical equipment is energized. An arc flash is a type of electrical explosion that can cause severe burns, blindness, and even death. It is important to take precautions to prevent arc flash, such as wearing appropriate PPE and following safe work practices. Lockout and tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on.